All right. Happy Friday, or I guess it's not really Friday. Today is Monday of Labor Day. So, yeah, Labor Day weekend, 3-day weekend, Monday morning, making a quick video. What did you do this weekend? I made a video. That's what I did. That was my big thing. But what are we doing today in class? I'll move my face out of the way here. Our goals for today, all right, are identifying congruent angles. We're classifying angles by their measures and identifying angle bisectors and trisectors. And we just want to get used to naming angles too, the basics within angles. All right. So here we go. Again, here are our goals for today. Name and classify. I recognize congruent angles and bisecting and trisecting angles. So, what am I? A continuation of our game here. Well, it's not really a game, but it's kind of a game. So, I am made up of two rays. Both rays have the same endpoint. That's key here. Both rays have the same endpoint. The common endpoint is called the vertex. So the vertex, this is the vertex of an angle. The two rays these are called the sides here. Okay. There's many ways to name me. Okay, I can be named by the number and side, so we can call this angle 1. We can name by 3 letters or a single letter at the vertex. Hopefully you should know what this is by now. It's an angle. Now, obviously, write down you don't have to write down every single thing word for word. Just get the gist of it when you're writing this stuff down. Okay. All right. Name these in different ways. So, like I said in this last slide, I can use a single letter. I can use a number, or I can use 3 letters. The safest way to name angles is using 3 letters, but we'll get into that later. So, name this in different ways. Well, now I got to figure out which okay, let me try that again. Which is my vertex? Which letter is my vertex here? Okay, my vertex here is always going to be this middle where our 2 rays meet. Okay, this is my vertex. J is the vertex. I'm going to circle J and write vertex. Okay, if I were you, I would write down these pictures and then the names as well. So the way to name these, I can use a single letter, so I can call it angle J. Okay, this little symbol here means angle. All right, now you may see it written like that, or sometimes in the book they just write it like that. Okay, there's a couple different ways. I will use that. Okay, I'll put the little slash through so it doesn't look like a less than sign. Another way to name this angle is based off 3 letters. Your middle letter must be your vertex. So what do I mean? I mean I, J, K, or K, J, I. Again, I can tell what the vertex is based on this middle letter here. Okay, let's look at this one here. All right, this is a good talking point. Okay, first way to name it, I can name it with a single letter here. That's our vertex, angle W. Second way, I can use 3 letters. So I'm going to go angle ZWX or angle XWZ. Now, you notice that there's that little 3 there. That 3 isn't the vertex. The vertex point is always a letter, all right? So W is considered the vertex. But that 3 is drawn in there, okay, to name the angle. So I can name it angle 3. I can't say Z3X, okay, or X3Z, because when naming angles using letters, I don't want to include the numbers. All right, numbers are placed in angles to make our lives easier. Okay, when we're doing things like proofs, all right, or we get to more complicated diagrams, a lot of times you'll see the numbers. You'll see more numbers than anything. Okay, let's try this one. Which angle is angle B? All right, name an angle so that may cause Never name an angle so that it may cause confusion. So if you look here, how many angles do you see? Well, there is this big angle here, KBM. There is this angle here, and this angle here, right? So angle B cannot be you cannot say which one is angle B. There is no angle B here. Why? Because there are multiple angles with B as a vertex. What do I mean by that? I mean, KBL could be included, or LBM would be angle B. Like we don't know because this angle here is, it's not necessarily bisected, it's just intersected by this angle there, by BL, by that ray. Okay, if this ray BL was not there, I could call this angle B. But since there are multiple angles within our whole thing, okay, then that whole thing, I cannot call an angle B. All right. And we'll go, I'll maybe we may have to circle back to that after this. All right. So there are three angles here. There's the whole angle and the two smaller ones. Whenever you have two smaller ones inside of a big angle, I can't use a single letter. So angle 2 could be this, angle KBL, or angle LBM. Angle 3 could be angle LBK. My mistake. I could do LBM. I was getting ahead of myself there. Holy buckets, how could I do that? Or MBL. All right, those are all the names there. That's pretty sick. That's pretty neat and sick. That's awesome. Wow. All right. Wow. Name two pairs of congruent angles instead as a congruency statement. So just like with segments, how we look for the corresponding tick marks, all right, angles are the same way. All right. Notice how with these segments, like there's 3 and there's 3 tick marks. So those two segments are congruent. Well, I'm going to do the same thing with my angles. All right. So if you look here, there's one tick mark there. So angle AMP is congruent to. Now I'm going to look at all of the tick marks on these angles. This is 3, so that's not the pair. This has 2 with the slash, that's not it. This has 2, no slash. This has 2 with a slash, and this has 1. So since this angle down here, FGT, has a matching tick mark to AMP, they are congruent. Similarly, hopefully you recognize something when I was looking at all these pairs. Here's 3, right? There's no other angle with 3 tick marks. Here's 2 with a slash. All right, so I have 2 with a slash. Here is 2 with a slash. So that means that that's our second angle pair. So I'm going to say, do a little like that, semicolon, angle MPA is congruent to angle CFG. Now, could I just call this angle P? Hopefully, you answer no. Only buckets. Okay. Why? Because there's 4 angles here. All right. I can't call this angle F because there's 1, 2, 3 angles there. You can't pick out which one you want. Okay. Part B. Oh wow, another name for angle 2. Well, here's angle 2. All right, angle 2. 2 is in the vertex. So what I like to think of it as, all right, how am I going to, if I have a little Pac-Man, the Pac-Man is eating angle 2. Is eating the 2. Well, if I extend it out indefinitely, I could say MHP would be another name, excuse me. MHP, or I could say A or M, holy buckets, MHA. So I haven't had my coffee this morning, but I'll get around to it. So either one, I could say, why can I say A? Well, because technically this is a ray, and rays go on forever. Same thing there. Right? Name 4 angles with a vertex of M. So I'm going to get rid of all that. Oops, didn't mean to do all that. I'm with the vertex of M. So let's see. Erase. Boom. Okay, so here's M at the vertex. So I could count this whole thing. Here's 1. Here's 1. Okay. And then you're just going to have to name 1 twice. So name 4 angles with the vertex of M. Go ahead and try that. All right, go ahead and give that a shot. I'm going to try to pause. I don't know if it's going to work or not, but I'm going to do my best. Mm-hmm. Okay, can't do it. All right, and we're back, I think. So these are the four that I came up with. All right. I said AMT and AMP. So if you look here, AMP, I could also say AMT because remember, these rays go on forever. You could have said HMP or HMT, HMA, AMH. Notice how in all of these options, M is the middle letter because it is our vertex. Okay, last slide for the video, angle classifications. So there's 4 different types of angles that we're going to talk about. We're going to refer back to these 4 types throughout the year. The first one is acute. So that's an angle. Let's see, I should probably type this, it might be better. All right, let me type this out here. And we're back. Okay, so I wrote this down. I typed it out because it probably would look better if I did. All right, so take your time, pause the video, get this down. An acute angle, all right, is an angle whose measure is between 0 and 90 degrees. I would write this so I could say that 0 is less than some angle x, less than 90 if you want to think about it as an inequality. All right, same thing with obtuse is between 90 and 180. Okay, so 90 is less than some angle x, which is less than 180. An angle measuring 90. I'm going to show you a little degree symbol. It's that little, like the little 0. Okay, it's like this, 90 degrees. And a straight angle is an angle measuring 180. I would have written out the word degrees, but I wanted to show you that symbol. All right. Okay, so congruent angles, just like congruent segments, they're angles that have the same measure. This is the important part there. Angles are, we call them measure. Segments, we say they have the same length. Okay. An angle bisector is a ray that divides an angle into 2 angles. So I'm going to draw one here. So let's say this is an angle. Here's an angle. It may look right, but I don't know if it is for sure. This blue line would be my angle bisector, and that would make these 2 congruent. Okay, I could say that here's 1 and here's 2. Angle 1 is congruent to angle 2. An angle trisector is just like a segment trisector. It's 2 rays that divide an angle into 2 congruent angles. So here's 1 ray, here's another ray, and now I have angles 1, 2, and 3. Actually, let's just numbers 3, 4, and 5. Sorry if you wrote that down already. This is congruent to this. This, I could say angle 3 is congruent to angle 4, and that is congruent. All right, that concludes our video for today. Okay, we will pick up in our groups with this portion here. This part we might do as a class more. So if you are confused with these 2 questions here, go ahead and go on to this one. Go ahead and go on number 4 and number 5 and 6 once until we put you guys back as a whole class. All right. Hopefully that helps. If you have any questions, let us know.